I'm Laura Cotton and I'm a micropaleontologist here at the Florida Museum of Natural History. I collected fossils when I was a kid and I basically just kept on doing that. Took a degree in geology, then did a PhD in forams, and now have a job in forams. Forams are single-celled organisms which have a calcareous shell and they live in the ocean. Most forams will fit into the eye of a needle. They look a little bit like dust when you look at them on a table. Actually, if I sneeze when I'm working, they'll all disappear. Forams have a really long fossil record and they have a really good fossil record. Because they're so small, you get a lot of them preserved in the sediments underneath the oceans. Researchers use forams to work out climate in the past. As they form the shell, they record a little bit of that ocean chemistry in the shell. And what you can do with this is, if you have a long record of them, you can look at this and how it changes with time. So the Eocene is from 33.7 million years ago to 56 million years ago. Researchers are interested in the climate of the Eocene because it was much warmer than today, and it also had higher CO2 in the atmosphere compared to today. And so it's a really good analogy for looking at future global warming scenarios. In this study, what we did was we analyzed the forams from the equator, and we found that the tropical regions were about 6 degrees warmer in the Eocene than today. And what we did with this data is used it to recalculate previous studies. This showed us that the polar warming was also much more than expected, according to some climate models. In terms of current and future climate, that has some important implications because a lot of the climate models previously thought that the poles weren't going to warm as much in the Eocene. If they're warming much more in the Eocene than we expected, then they're probably also going to warm more than expected in future scenarios.